Bye-bye.
And now,
Thanks.
last but not least, we move to our last speaker for in this track, with Dr. Doina Caragea. She is a professor at Kansas State University. Her research and teaching interests are in the areas of AI and machine learning, with application to crisis informatics and security informatics, among others. Her projects build upon close collaborations with social scientists, security experts, and life scientists. And really, she aims to provide practical computational approaches to address real-world challenges. She received her PhD in computer science from Iowa State University in August 2004, and was honored by the Iowa State University Research Excellence Award for her work. She's honored also with an Engineering Frankenhoff Outstanding Research Award and the Roots of Research Award. She's published more than 150 researches in conferences and journal articles, and she has a very strong record in extramural funding, over 15 million plus in total funding, and she's been working with senior personnel from NSH, NIH, ONR, and industry. So really, it's a pleasure to have you join us. I know this is early morning for you, Doina. I really appreciate this. So the floor is yours.
Thank you so much, Mariette. Good afternoon, good morning, depending on where you are. Thank you for inviting me to speak at this event. The talks I've been listening so far have been truly inspiring, and I am honored to be here as one of the speakers, and I'm happy to talk about one of my projects that is on using social media and large language models to aid disaster response. So I'm hoping that will help see some of the some of the benefits of social media. As the title here says, the main goal of this project is to help disaster response teams, and we aim to do this by identifying and filtering useful situational awareness information that is posted by affected individuals on social media. Our focus in this project has been mostly on natural disasters, but the approaches and techniques we are using can be used for other types of crisis events. Of course, we all know that deadly disasters happen all the time, and it seems that their frequency and severity has increased in latest years. Just in 2024 alone, there were 393 reported disasters, almost 17,000 deaths from these disasters, more than 167 million of affected people, and huge economic losses totaling approximately 242 billion. And when a disaster happens, the traditional emergency lines usually become overwhelmed with a number of calls, and one may need to wait on the line while they can get anybody to talk to. So what if the power goes off? What if the phone battery dies? In recent years, we have seen more and more people turn to social media to ask for help. And there are many examples, but in particular during the Turkey-Syria earthquakes in 2023, there were social media posts made by trapped people that essentially saved their lives. The posts were on Twitter, on the WhatsApp, various social media platforms, but the bottom line is that those posts that they made saved their lives. And as part of the rescue efforts, there was a company called Open Source Network that used social media and AI to map addresses that required search and rescue operations, and this contributed to saving lives. Of course, there are millions of posts and messages that emerge on social media within hours. And some of these posts contain useful situational awareness information, including location information. But to be useful to make use of this large amount of unstructured information that is posted, we have to transform it into actionable insights. And this is not an easy task. There are so many posts, and some are useful, some are less useful, that responders are really faced with information overload. They need to find a needle in a haystack. So how can we identify useful content on social media? Principle we can use simply search to like keyword-based search, location-based search, but direct search is usually noisy and a lot of non-relevant posts will be retrieved. Of course, manual triage is not an option because it delays critical decisions and resource allocation. So there is a big need for tools that can automatically filter relevant, informative, and actionable information that is posted during disasters in real time. To perform such filtering, we can proceed in a hierarchical manner. We can first identify posts that are relevant to the disaster. Then among those that are relevant, we want to find those that are informative, generally those that are posted by affected individuals. And then we want to categorize them as posts related to damage, posts related to injured people, donations, and so on. Large language models, such as ChatGPT, are particularly attractive tools in this context, as they can summarize, classify, translate, reason over data streams at machine scale, and they can accelerate situational awareness. But of course, we know that they are not perfect, they can hallucinate, so analysts and local responders need to stay in the loop to verify outputs, to add context to ensure that ethical decisions are made. So in our project, we have explored the use of large language models to filter disaster posts, and we have a paper that we recently presented at the International Symposium on Foundations and Applications of Big Data Analytics that was held in conjunction with SONAM earlier this fall. So in particular, we focused on multimodal disaster-related tweet classification with parameter-efficient fine-tuning of large language models. In our study, we used an existing publicly available data set that was published by Hoffley et al. In 2018. And this data set has two main classification tasks. One is called tweet informativeness, and here the goal is to classify tweets as informative or relevant, to having relevant disaster content or non-informative. And then the second task is to categorize tweets according to several humanitarian categories, including affected individuals. And here we have tweets about injured or dead, about missing and found, then rescue volunteering and donation efforts, infrastructure and utility damage, other relevant information, and then not humanitarian information. So The data set is a multimodal. It contains both text and images. So these are posts, tweets that have both text and images. And we split them into training, development, test subsets as is standard in machine learning. But overall, there is a large number of labeled tweets for both tasks, a little more for the tweet informativeness. So here are some examples of multimodal posts from this data set. Again, image and text for each of the posts. And our goal was to evaluate multimodal large language models in zero and one-shot settings. Zero shot means you use the model out of the box, you don't give any examples, you don't do any training. One shot means we are giving an example in each of the categories that we want to classify the tweets in. And we used three models here, zero shot and one shot settings. The GPT-4o, and this is a pretty large model. I think it has about 200 billion parameters. That is a lot. GPT-4o mini, that's a small version. It has about 8 billion parameters. And then Llama. So those are proprietary models from OpenAI. Llama is from Meta. We used Llama 3.2, 11 billion. This is an open source model that we could also fine-tune. And we fine-tuned it using parameter efficient fine-tuning, specifically low rank adaptation. The prompt engineering included explicit instructions, category labels, and some brief explanations for the humanitarian categories. I have here as an example the prompt that we used for the informativeness task for Llama. We asked the model to, if the given text image pair contains useful information that could help crisis response. We asked the model to respond with 1 if the text and the image provide information or details about the crisis, and 0 if they don't. And then we give some other more specific instructions. We want the model to prioritize identifying text and image pairs that provide relevant details, even if they are brief or incomplete. We want the model to avoid being overly restrictive. If the text and image have any relevant crisis-related information, we want the model to respond with 1. But if the content of the text-image pair is unclear, we ask the model to respond with 0. And we also ask that the model does not output any extra text, and that's just for easiness of processing the output. So here are some results, and the clip approach at the top was state of the art on this exact data set with this exact splits. And then I have the zero-shot results with the 3 models we used, the one-shot results, and then the results of the fine-tuned Llama. And we can see that the GPT models show very good performance, both zero-shot out of the box and one-shot. They significantly outperform Llama. And surprisingly, the smaller GPT-4o mini model gives the best overall results, which is good because it's more cost-effective. We also see that fine-tuned Llama, so when we use some of our training data to fine-tune the model, given that it's open source, we have access to the weights, we can fine-tune it with disaster data. The results were better than the previous state-of-the-art results on that data set. So zero-shot and one-shot multimodal large language models demonstrate very good generalization abilities. The fine-tuned models consistently outperform the zero-shot and one-shot settings for both tasks that we explored here, that we worked on here. Fine-tuning the Llama model gave state-of-the-art results, highlighting the power of open source models that are optimized. And the final message here, that task-specific fine-tuning is crucial for real-world deployment, and open source models can serve as practical, scalable, and cost-effective alternatives to proprietary solutions in crisis-related social media classification. So I mentioned the disaster map from the Turkey-Syria earthquakes. So as part of our future work, we are looking into how can we leverage LLMs to aggregate disaster maps, for example, to create a damage map from social media, multimodal social media posts. And I already mentioned earlier that when people eyewitness of disasters post on social media, they post very useful situational awareness information and location information as part of the text. These are some images from a storm a few years ago that did a lot of damage in Iowa and then moved to Chicago and did significant damage also there. And I took one of the posts, the text of one of the posts, and I asked ChatGPT 5 to find the locations in that post. It thought for 27 seconds, but it was able to find city, Marion, Iowa, and then identified an intersection, and it also created a map. I click on that map, it's showing the center of the city, it's showing the intersection where the damage was. So there is definitely capability for large language models to help build disaster maps, and that can happen as the disaster happens instead of waiting and collecting data after. So the final takeaway message here is that LLMs can enhance crisis response, make it faster, especially when paired with safeguards and human oversight. And I want to end by acknowledging my current and past students and collaborators who have contributed to this project, the crisis informatics project over the year. Thank you, and I'm happy to take any questions you may have.
Thank you, Doina. So any questions? Yes.
Hi, I have two questions. The first one is related to the choice of the platform, why Twitter? And the second one is related to what if the user-generated information was generated by AI, or if it was information, how do you manage this?
Those are great questions. Why Twitter? Before, I don't remember what year, a couple years ago, the policy of Twitter changed. But before that, Twitter offered an API, especially for academic purposes. You could crawl a lot of data and learn a lot about public perceptions from that data. Twitter made it at that time easier than X is making it these days. So that's why people collected a lot of Twitter data and worked with Twitter data. There are other data sets now, or people are looking at other social media platforms, of course, and this is just an example. The second question, what, can you please say that again?
Yeah, the second question was about false information, AI-generated content.
Oh, false information. Yeah, definitely. That is a big concern, and that's why I said you can't directly trust all the information. You still have to have a human in the loop. But there is a lot of research as another area on identifying misinformation. And of course, it's related, and we have looked at some of that, but I'm not necessarily addressing that here. But that is a big issue. So, as part of filtering, you also want to filter the misinformation in the first place.
Maybe one last question, if sure, Jihad.
Thank you very much. Very informative discussion, presentation. I come from the background of public health. And in public health, we're very much interested in management and responses. But in public health, we always work in teams, multidisciplinary teams. So a quick question comes to mind. Can you tell us a little bit about what kind of expertise or experts or backgrounds did you have with working with you? In addition to, of course, the various computer science and computer engineering backgrounds. I would love to know. Thank you so much.
I have one of my collaborators here, Dr. Andrea Tapia from Penn State University, who is in social sciences and works with a lot of crisis organizations, disaster organizations. So this was part of a bigger project, and she was the person who was bridging with organizations. Here locally, I have talked to emergency management people, and I do not have funding for this project right now, but we are looking into potential funding and collaborations more at a local level for the future.
Thank you so much. Really, it was very an interesting presentation. I'll probably follow up offline with you with a lot of questions, definitely about the choice and then the mapping. We've done some work earlier when we had the unfortunate explosion in Beirut. It wasn't back then LLMs, but we tried to generate these maps. So there's tremendous opportunities for AI, Gen AI, to help in such situations. So we close with this track with this last presentation. So please help me really thank Doina for her very interesting presentation. Thank you so much. We appreciate you joining us online in a different time zone. Hopefully we got to host you some other time in Beirut in person. Thank you.
I would love that.